Hello children, welcome back to chemistry session. In last session, we have seen methods to express concentration of solution. In that, we discussed the methods like parts per million, that is ppm method, molarity, molality, and mole fraction. In today's session, we are going to talk about solubility of solids in liquids and solubility of gases in liquids. Let us start today's section, children. Solubility of solids in liquids. What is done by solubility? Solubility means the maximum amount of solute that can be dissolved in the given solvent at a given temperature. For example, the solubility of common salt is 36 grams. So 36 grams of common salt can be dissolved in 100 grams of water at 25 degrees Celsius temperature, that is room temperature. That is known as solubility of common salt. That can be defined the maximum amount of solute that can be dissolved in given solvent at certain temperature. When we talk about solubility of solids in liquids, generally solids can be classified into two types. Those are polar solids and non-polar solids. Polar solids and non-polar solids. How can we define polar and non-polar solids? Suppose the solids which contain ionic bond or ionic solids are called as polar solids, or crystalline solids are also called as polar solids or ionic solids. For example, sodium chloride, NaCl, magnesium oxide, MgO, calcium chloride, CaCl2, etc. These are some of the examples of polar solids because these solids contain ionic compound, ionic bond. That's why these are called as polar solids. And these polar solids soluble only in polar solvent. Example of polar solvent is water. What is meant by polar solvent? Polar solvent means the solvent which has high dipole moment value. What is meant by dipole moment? Dipole moment is the product of, it is denoted by mu. Dipole moment is denoted by mu. Mu is equal to charges of the charge species and d. D means distance between the two charge species. This is called dipole moment. For example, we have another here H2O molecule. H2O is nothing but central atom is oxygen atom and these two are hydrogen atoms. This is the structure of H2O and here oxygen atom and this is hydrogen atom. And when we talk about electronegativities of oxygen and hydrogen is 2.1, oxygen electronegativity value is 3.5. So oxygen has more electronegativity value than that of hydrogen. That's why different charges develops on the atom. It is denoted by this arrow mark with a tail. So this is tail of the arrow mark, this is head of the arrow mark. This tail of the arrow mark indicates the element which has low electronegativity and head indicates element which high electronegativity. That means electrons are shifted towards high electronegativity atom. This phenomenon is known as dipole moment. Here these two atoms, these two bond atoms are separated by a distance that is denoted by small d. And these two are charge species. Here oxygen has negative charge delta minus and hydrogen has positive charge delta plus. Here delta plus and delta minus indicates partial charges present on them. Here delta plus delta minus are their magnitude of the charges and they are separated by the distance is denoted by d. So mu is equal to q into d is called as dipole moment. And this dipole moment is expressed in debye. Units of dipole moment is debye. Its notation d. So the solvents which have resultant dipole moment values are called as polar solvent. Example, water. In general, polar solids are readily soluble in polar solvent because polar solvents have high dipole moment value. That is the reason why ionic compounds or electrovalent compounds, they are readily soluble in polar solvent. And coming to non-polar solids, non-polar solids are also called as molecular solids. Example of non-polar solids, camphor, naphthalene, and anthracene, etc. Camphor, naphthalene and anthracene are some of the examples of non-polar solids. They are also called as molecular solids. They do not soluble in the water. They only soluble in the benzene because non-polar solids readily soluble in non-polar solvent. Non-polar solvent. Example of non-polar solvent is benzene. Formula of benzene C6H6. Not only benzene children, phenol, aniline. There are some of the examples. Most of the organic solvents acts as non-polar solvent. Here, the compounds like camphor and naphthalene both and anthracene readily soluble in benzene is a non-polar solvent. Why polar solids only soluble in polar solvent? On the other hand, non-polar solids only soluble in non-polar solvent. This is on the basis of intermolecular interactions. Intermolecular interactions are similar in these two. Suppose intermolecular interactions of polar compounds and polar solvents are similar, and on the other hand, intermolecular interactions of non-polar solids are similar to that of non-polar solvent. And it is also on the basis of the statement like dissolves like. Like dissolves like. This statement tells about polar compounds only soluble in polar solvent. Non-polar compounds soluble only in non-polar solvent. This is on the basis of the statement like dissolves like. Okay. Now, when solid dissolve in the given solvent, what will happen? When a solid dissolve in the given solvent, then solid soluble in the given solvent, which forms a solution. Because we have seen in earlier class that solution is a homogeneous mixture of solvent and solute. When a solid solute dissolve in the solvent, which forms solution? And we know types of solution: saturated solution, unsaturated solution, and supersaturated solution. What do you mean by saturated solution? Saturated solution means when required amount of solute present in the given solvent is forms saturated solution. Unsaturated solution means when a solute has less percent than its requirement, which forms unsaturated solution. Supersaturated solution means when a solute present more than its requirement, which forms supersaturated solution. These are types of solution on the basis of amount of solute present in the given solvent. It's called saturated, unsaturated, and supersaturated solution. So, when we add solid solute to the given solvent, which forms solution, it may be saturated or unsaturated or supersaturated on the basis of amount of solute present in the given solvent. But most of the solid can be dissolved in the solvent, which forms solution. The process called as dilution. But some of the solute particles may not be soluble in the given solvent at the given temperature. Then the solute which do not dissolve in the given solvent, which separate out of the dilution, is known as crystallization. So we have to consider in such a way that dilution as well as crystallization. What is meant by dilution? Dilution means dissolving solid solute in the given solvent is called as dilution. And crystallization means a sum of the solute particles cannot dissolve in the or cannot soluble in the given solvent is called as crystallization. We have to assume that these two must be in dynamic equilibrium. Dynamic equilibrium means rate of dissolution must be equal to the rate of crystallization. For example, let us say x grams of solute dissolved in the given solvent. Similarly, x grams of solid solute may not be soluble in the given solvent. That is equal to rate of dilution is equal to the rate of crystallization. We have to assume the rate of dilution must be equilibrium with dynamic equilibrium with rate of crystallization. These two are in the equilibrium position. That means rate of forward reaction is equal to rate of backward reaction in case of equilibrium. Now, what factors affect solubility of solids in liquids? This is the factor. The factor is nothing but temperature. Effect of temperature changes solubility of solid in a given solvent. How can we tell that temperature change affect the solubility of solid in liquid? This is on the basis of Le Chatelier's principle. Le Chatelier's principle states that when we change any one of the factors such as concentration or temperature or pressure or addition of inert gas, when we change any one of the factor, then the equilibrium is shifted in such a way that to reduce the additional factor or minimize the additional factor, because we have assumed that or we have considered that rate of dilution is equal to the rate of crystallization. So this is in a equilibrium, dynamic equilibrium state. That's why here we have to follow Le Chatelier's principle. Le Chatelier's principle states that when we change any one of the conditions of temperature or pressure or concentration or inert gas, then equilibrium is shifted in such a way that to minimize or to reduce the additional product or additional factor. So, effect of temperature is affects the solubility of solid in a given solvent. Let us see endothermic and exothermic reaction, because when we talk about temperature related to the solubility, we should talk about exothermic and endothermic reaction. Exothermic reaction and endothermic reaction. What is meant by exothermic reaction? Exothermic reaction means during chemical reaction, energy is liberated. So when a chemical reaction has taken place, when energy gets liberated, such reactions are called exothermic reaction. The change in enthalpy denoted by delta H. The delta H sign for exothermic reaction is negative. So delta H is equal to negative for exothermic reaction, because delta H means enthalpy change. Enthalpy change is negative for exothermic reaction. Coming to endothermic reaction, during a chemical reaction, energy is absorbed or energy is required for endothermic reaction. Delta H symbol or change in enthalpy for endothermic reaction is positive. So delta H is positive for endothermic reaction, negative for exothermic reaction. Example of exothermic reaction is addition of sodium hydroxide to water. When we add sodium hydroxide to water, the sodium hydroxide solids are slightly soluble in the water. Then when you touch the bottom of the beaker, then we feel hot, because during chemical reaction energy is liberated. So that is an example of exothermic reaction. For exothermic reaction, change in enthalpy value is negative. Addition of oxalic acid to water. When we are adding oxalic acid to the water, when we touch the beaker, we feel cool, because energy is absorbing from the surroundings. So energy gets absorbed or energy required during a chemical reaction. Such reactions are called endothermic reaction. For endothermic reactions, change in enthalpy is positive. When we talk about solubility of solids in liquids, in case of endothermic reaction, solubility of solids and liquids increases with increasing temperature. That means solubility is directly proportional to the temperature change. Solubility is directly proportional to the temperature change. This is for endothermic reaction because endothermic reactions require heat energy. That is the reason why as temperature increases, solubility of solids and liquids also increases. In case of exothermic reaction, it is controversy to endothermic reaction. Here, solubility of solids and liquids decreases with increase of temperature. So we can say that solubility is inversely proportional to the temperature. Solubility is inversely proportional to the temperature. This is because during exothermic reactions, energy liberated. So when temperature increases, we are giving energy to the system. When we are giving energy to the system, then solubility of the solid in a given solvent decreases. That is the reason why solubility decreases in case of exothermic reaction. Solubility increases with increasing temperature in case of endothermic reactions. So this is the effect of change of temperature. Next, how does pressure changes solubility of solids and liquids? When we change the pressure condition, then pressure doesn't affect the solubility of solids and liquids because solids and liquids have intermolecular force of attraction among the particles and they have uncompressible. They are not easily compressible. That is the reason why pressure doesn't affect the solubility of solids and liquids. This is affect solubility of solids and liquids. So in that we have discussed about types of solids and temperature effect of temperature and effect of pressure. And let us talk about solubility of gas and liquids. And we know that many atmospheric gases like oxygen, nitrogen, carbon dioxide are soluble in the water. And when we apply pressure on the gases, then gases are readily soluble in the given solvent. For example, carbon dioxide gas. When we apply pressure on the carbon dioxide gas, then carbon dioxide gas is soluble in the given solvent, that is nothing but soda water. So we use this technique in beverages or soft drink industries. This is because when we apply pressure over the gaseous system, then the gaseous molecules are diffused into the liquid solvent. So initially the solvent molecule, the liquid solvent have less gaseous molecule dissolved in them, but when we apply pressure over the gaseous molecules, then gaseous molecules mostly dissolve in the given solvent because we are reducing the volume of the system. When we reduce the volume of the system, that is possible when we apply pressure on the system because the relation between pressure and volume is inversely proportional to each other. When we increase or when we apply pressure over the system, then gaseous molecules occupies lower volume. When they occupies lower volume, then many gaseous particles present in the smaller volume. That means number of gaseous particles can easily dissolve in the given solvent. But at the same time, some of the gaseous particles may not be soluble in the given solvent. Let us say X number of gaseous particles are dissolving in the given solvent and simultaneously X number of gaseous particles are coming out of the dilution. Number of gaseous particles entering into the solution is equal to the number of gaseous particles coming out of the solution. If it is possible, then there is a dynamic equilibrium exists between the two systems. And Henry was the first scientist to give a quantitative relationship between the solubility of the gases in a given solvent. And not only Henry, Dalton had also given relation between the amount of gas soluble in the given solvent is a function of mole fraction of the gas. So Henry's law states that the partial pressure of a gas in vapor state is directly proportional to the mole fraction of the gas in the solution. I am repeating, children. Henry's law states that the partial pressure of the gas in vapor state or the partial pressure of the gas in vapor phase is directly proportional to the mole fraction of the gas in the solution. That means partial pressure denoted by P. P is directly proportional to the mole fraction of the gas. Mole fraction of the gas is chi. That it can be written as P is equal to Kh into chi. So P is equal to Kh into chi is the chemical representation of Henry's law. Where Kh is called as Henry's constant. Henry's constant. This Kh value is different for different gases. This Kh value is different for different gases at the same temperature. If we change the temperature value, then Kh value of same gases also changes. The textbook they have given the tabular form Henry's law constant for some gases. You can go through the textbook. You can go through the Henry's law constants for different gases. Then you will understand that how Henry's law constant varies with respect to the temperature. So at the same temperature, different gases have different Henry's law constant value, and same gas have different Henry's law constant values at different temperature. And one more point, as Kh value increases, solubility of gas in a liquid solvent decreases. That's why Kh is inversely proportional to the solubility of gas. Henry's law constant value is inversely proportional to the solubility of gas in a given solvent. This is because as Kh value increases, less amount of gas can be soluble in the given solvent. That means as Kh value is directly proportional to the temperature. It's a function of temperature. That means as temperature value increases, Kh value increases. As Kh value increases, solubility of gas and liquid decreases. That's why as temperature increases, solubility of gas in a given solvent decreases. What about pressure? Pressure increases, solubility of gas in a given solvent is increases. That's why pressure is directly proportional to the solubility of the gas in liquids. Pressure increases, solubility of gas increases. Temperature increases, solubility of gas in a liquid decreases. And when we plot a graph between partial pressure and the mole fraction of gases, it is something like this, children. Partial pressure on x-axis in terms of atmosphere, pressure expressed in atmosphere, and chi means mole fraction. Mole fraction is expressed in mole or millimoles. Now the flat is passes through the straight line. It is something like this, children. The flat is passes through the horizon. So this proves that here Kh is a function of temperature, and as temperature value increases, Kh value increases. As Kh value increases, solubility of gas in a liquid solvent decreases. This is called Henry's law. Once again, I am telling Henry's law, children. Henry's law states that the solubility of a gas in a given solvent or the partial pressure of the gas in vapor phase is directly proportional to the mole fraction of the gas in the solution. Here P means partial pressure of the gas in vapor state, because we know that gases possess pressure that is called as vapor pressure, because gas is in vapor state, and chi is mole fraction of the gas. Partial pressure of the gas in vapor phase is directly proportional to the mole fraction of the gas in the solution. This is called Henry's law. Now let us talk about application of Henry's law. In daily life, this Henry's law plays a crucial role or an important role. Let us see. We have seen that beverages are soft drinks. These beverages or soft drinks are sealed under high pressure. This is because these beverages or soft drinks or cold drinks are made up of aqueous carbon dioxide gas. This carbon dioxide is dissolved in a given solvent, that is water, at high pressure conditions. So under high pressure conditions, most amount of carbon dioxide is dissolved in a given solvent, that is contents of the beverages or soft drinks. And one more point, scuba divers. Scuba divers means which will go into the depth of the oceans and seas. While going to them, when they are going to the depth of the oceans and sea, they carry artificial gas cylinders. Those artificial gas cylinders are made up of mixture of gases like helium, oxygen and nitrogen, because when they go into the depth of the oceans and seas, their pressure is more. We have discussed that at high pressure condition, the solubility of atmospheric gases in blood also increases. So at that condition of pressure, at high pressure conditions, most amount of gases can be dissolved in that. That is the reason why they carry these artificial cylinders which made up of or which are concentrated with high gases like helium gas, oxygen and nitrogen. And when they come to the surface layer of the water, or when they comes to the surface of the water, then they have low pressure condition. So at low pressure condition, when this gaseous mixture releases nitrogen gas, because we discussed that this has mixture of gases like nitrogen, helium and oxygen. So when they come to the surface of the water, then pressure is decreases. When pressure is decreases, what happens? These atmospheric gases are diffused in the blood. That means the major composition of the artificial gas cylinder is, artificial gases mixture is nitrogen. So when the nitrogen is diffused in the blood, then this nitrogen forms blocks capillaries. That means this nitrogen forms bubbles in the blood vessels. That is nothing but this nitrogen gas forms capillaries in the blood vessels. So whenever this nitrogen forms capillaries in the blood vessels, it stops the flow of oxygen, flow of blood in the blood vessels. Then it causes bends and it affects human life as well as biological life. To prevent that, we use the gaseous mixture. We use the gaseous mixture of liquid helium and oxygen and nitrogen. That's why whenever we go into the deep of the ocean and sea, we use the artificial gas mixture, because at that condition temperature is more, pressure is more. At high pressure, maximum amount of oxygen can be soluble in that. Maximum amount of oxygen is required. So in this way we can supply more amount of gases. And third factor, at high altitude conditions, amount of oxygen in the blood is decreases, because at high altitude conditions vapor pressure is less. At vapor pressure is less amount of oxygen in the blood. When less amount of oxygen in the blood, it causes disease like anorexia. Anorexia means unable to think. They may not think properly. That is called anasia. So the people who are suffering from this disease, who is living at high altitudes, are sometimes climbers. That's why climbers carry artificial oxygen cylinders, because at high altitudes vapor pressure is less. That means amount of oxygen levels are low in high altitude condition. That's why these climbers carry oxygen cylinders. So these are the applications of Henry's law in daily life. This is today's session, children. In today's session, we discussed about solubility of solids and liquids and solubility of gas and liquids. I hope you understand today's session, children. We will meet in next session. Thank you.